mesh current states that two imaginary currents that we define, the difference between them is equal to the branch's current, as long as we have all of the imaginary currents for all the loops in our circuit. So let's begin with the first two loops. I1 minus this current, which is going this way versus this way. That is the current of this branch, essentially going this way, minus I3 times 15 ohm. And then we have our, since this is a KVL, we have to minus 22 volts this way. And then plus I1, because we're going now this way, times 14 ohm. And then we have our minus 3.4 times IC. And all this is equal to 0. So this is our loop. This is our KVL. Going on to this loop right here. And we actually see that there's a current source in between two loops with no resistor. This means it's a super mesh. So our next one, we will label this 2 plus 3. And we will have to also write a constraint for it. Our constraint will simply just be, we can say, what is it, 1.2. So we can say the current going this way minus the current going this way is simply equal to 1.2 amp. So we'll write that here. I3 minus I2 is just equal to, what was it, 1.2 amp. Now we have to write our, I guess, second equation, or our constraint for that. And that is that I2, if we look up here, is equal to 2.3 VA. So let's write a constraint, and that is I2 is equal to 2.3 VA. Go ahead and do it the way we did it in number 1. So that is going to be I4 minus I2 times 12. I2 times 12 ohm. And that's our KVL. And then we now have this one. So I4 minus I3 times 16 plus that's our voltage there. And then that's it for the whole loop. Now we go into the next loop right here, 5. So we have minus 4.5 VE, and then just plus I5 times 13 ohm is equal to 0. So that is this voltage, and then we come back down around here, and the current, since there's nothing on this side, there's no imaginary loop current going up this way, so it's simply equal to I5 times 13 is our current going through that branch. So now we go into our 6th and our 7th loop, and we see that there's actually a super mesh right here. So we have to do two equations for this one, and this will look like I6 minus I7 is equal to this number right here, 5.6. So let's write that. I6 minus I7 is equal to 5.6 S times VB. Now, for this, we also have to write a constraint. I guess this is actually our constraint, so we can just write a constraint there. And our actual equation is going to look like this. So we're going to have 22 volts plus 22. If we start here, we're going to write a KVL essentially going like this. So we have plus 22 volts. So we have plus 22 plus I7 minus I3 times 17. Was it I3? Yes. Minus I3, not plus 17, sorry, times 17 ohm. And then I7 times 19 plus I7 times 19 ohm. And then plus I6 times 18 equal to 0. So that's our entire KVL there. Now we have to go, and we notice we don't actually need this loop. This is because, well, I guess we kind of do for this IC actually, because we need it up here. But we notice that I8 is just equal to 1.75 because there's no imaginary loop defined on this side. And so 8 is just equal to 1.75 amp. All right. So now we still have a few KVLs we need to write. We need to write one for this one, VB this one, because it is right here. And we also need one for VE to solve this problem. All right. So let's go ahead and make a new thing for our KVLs right here. We can just write it right here. All right. So our first KVL, let's do VA. So we're going to do minus VA minus 22 plus I1 times 14 minus 3.4 times IC plus I1 minus I3 times 15 equals 0. So let's go minus VB. Let's write that a little more here. Minus VB plus I3 minus I4 times 16. And just follow along. We're going this way now. So we're on the 17 resistor plus I3 minus I7 times 17 plus I3 minus I1 times, this is around here, what is this, 15 times 15, and now we just have this resistor times 11. So all this is equal to 0. So let's do minus, here, it's just, so we have minus VE plus 1, 2 minus I4 12 plus I3 minus I4 16, and then might have gotten lost here. Aha, okay, so there's actually no current going here, so we don't have to write that. So essentially this is our final answer. Yeah, and then we have one final equation, which is kind of all this. I8 right here, we just have to remember that that is equal to, that's going like this, so I7 minus I8 is equal to IC, because that's a dependent. Yeah, so that's everything we need to know. That's all the equations. 12 equations, 12 unknown.